Hello everyone. When we convert a screenshot into code, how do we make sure the fine-grained components don't get lost? This video is inspired by Professor Liu's work, DCGen. It decomposes the web page into smaller segments. However, its division stage mainly relies on the visual separation rather than the explicit semantic UI component decision. So, it'll contribute to the omission of fine-grained components. My idea is to explore a complementary way, adding a YOLO layer, which is a semantic component grounding layer before the MLLM code generation. I trained a lightweight YOLO detector to identify the UI components. The detector outputs the component's labels, bounding boxes, and the confidence scores. And then I converted them into a structured JSON scaffold to help generate the website. I did two experiments. In the first experiment, I compared the direct prompting with the YOLO scaffold-guided generation. The direct prompting uses only the screenshot. The other one uses the same screenshot plus the complete YOLO scaffold. Well, the result shows that they both generate a reasonable web page, so the visual difference is not very significant. But the main value of the scaffold here is the feasibility, which tells the model what component should exist, reducing the chance of a sudden omission. The second experiment studies the roles of the screenshot and the scaffold as two information sources. When a screenshot is provided, the MLLM can recover the missing component from the visual input, even if the scaffold is incomplete. Well, this suggests that the model combines the visual information with the scaffold information. When a screenshot is removed and only the scaffold is provided, the result depends more strongly on the scaffold itself. If the scaffold is incomplete, components such as the input field or explanatory text are more likely to be weakened or omitted. Therefore, this experiment is not a fair performance comparison, but a sanity check showing that the scaffold has a structural control over the component generation. In short, my idea is not to replace the DCGen. It provides a possible complement when detecting the components. The current prototype is still limited because the detector was trained on a relatively small dataset and for a limited time. With more data, longer training, and more complex web pages, I believe that a semantic scaffold can help reduce missing elements and make the UID code more effective. That's all. Thank you.